Right, ladies and gentlemen, it's your last section here. All right. So I'm starting it off with a couple of application problems from yesterday still. So in a lab, 510 cells are present at the beginning of an experiment. During the first 6 hours, the number of cells increased by 16% each hour. Write an exponential model giving the number of cells Y present T hours after starting the experiment. Estimate the time when the number of cells is 800. So on this, remember, for our equation, it's y is equal to a times b raised to the t power. All right? So remember, it's a 16% increase, so that would tell us that b is equal to 1 plus 0.16. Okay? So if that's the case, then I can write my equation as y is equal to our initial amount is 510, and 1 plus 0.16 is 1.16, and we're going to raise that to the t power. All right? So then they want us to estimate the time when the cells is equal to 800. So that tells us that our y is equal to 800. So we have 800 is equal to 510 times 1.16 raised to the t power. All right. So then, remember, I can divide both sides by 510. So if I do that, I'll get that 1.16t is equal to 800 divided by 510. You have matching zeros there, so you could actually say it's 80 over 51. All right? So now remember, to take and get that t, which is an exponent now, to take it down, you're either going to take the log of each side or the natural log of each side. So I went ahead, and this time I took the natural log just because it's easier on the calculator. And then to get t by itself, so I'm going to go up here. To get t by itself, you're going to divide the natural log of 80 over 51 by the natural log of 1.16. All right? And then, so our time, when you look at it, it'll say the time is equal to 3.033. And let's see, it was hours that we were, which was our units. Okay, so that's it right there. So this next example, I'll just leave it in my notes. I'm not going to go ahead and do it because there's not one on the test, and there isn't one in the test bank that they give you. So if you want to see what that one looks like, it'll be in the copy of the regular notes. All right? Or I can show you later on if you really want. But it's kind of cool because you have to use Newton's law of cooling twice to find out when the temperature happened. So, but since there's not one on the test, like I said last year, I used it as an extra credit question on the test. All right, so now we're to the 6.7 part. All right. So to get to the 6.7, you have analyzed finite difference of data in chapter 4 for exponential data with equally spaced inputs. The outputs are multiplied by a constant factor. So consecutive outputs form a constant ratio. So on the first one, okay, they're asking us, example 1, determine the type of function represented by each table. So we're looking at the x here. And as we can see, it is going up by 1 each time. And a ratio, remember, is something over another number, and it's being multiplied. So if we look at this, we're going to have 243. And what do I multiply it by to get 81? Well, I'm dividing by 3, or I'm multiplying by 1/3. Same thing when I take 81 and divide it by 27. All right, and 27 divided by 81, 99 divided by 27. Again, I'll multiply that by 1/3, and 1/3 of 3 is 1. So it does work. It is a constant ratio, so this one here is exponential. So I think they're just going to ask you on the homework to tell if it's whether it's exponential or whatever else it is. On this one right here, it is going the same. It's going by +2. But if you take 13 over 5, it's not the same as 5 over 13. So right there, that tells you that it's not a constant ratio. So what you have to do then is remember in chapter 4, we took the differences. And on the first difference, you'll get 5 minus 13 is -8. 13 minus 5 is 8. 37 minus, etc. That's 24. 77 minus 37 is 40. And then we have 56. So since those aren't the same, we know it's not linear. I think in chapter 4, we ended up going to the third differences. So let's try the second differences. And again, if I take that, and that's 56, by the way, I'll have 8 minus a -8 is 16, 24 minus 8 is 16, 40 minus 24 is 16, 56 minus 40 is 16. So those are the same, so you know that the second one is a quadratic function, and that's all it's asking you to tell it. Okay? So you know that 2 points determine a line. Similarly, 2 points determine an exponential curve, and we've done something like this before. So write an exponential function, y is equal to a times b raised to the x power, whose graph passes through 1 and 10 and 3 and 40. Okay, so substitute coordinates for the given points into y is equal to a times b raised to the x power. So again, here's an x and a y. Here is an x and a y. And they're telling us to plug it in. So on the first one, we're going to say that 10 is equal to a times b raised to the first power. The second one, you're going to tell me that 40 is equal to a times b cubed. All right. So now you're going to solve it for the easier one. All right. If you have one that's a squared and one that's a fifth, you'll solve for the squared one. All right. And you'll kind of see here. So on the first one, we're going to solve it for a. So I'll get a is equal to 10 divided by b. And then wherever I see a in the second equation, I'm going to replace it with that. So in the second equation, I have 40 is equal to, well, our other one was 10 over b times b squared. Oh, excuse me, b cubed. All right. So now that 40 is equal to 10. Well, that b and one of those will cancel, so that'll be b squared is equal to b squared. And now you want to solve for b. And then we'll have b squared is equal to 4 or b is equal to the square root of 4, which is equal to 2. So then we have to determine what a is, and then write the function. So a is going to be 10. Our answer for b was 2. And that'll equal 5. So now that you have your a and your b, you can now write the function. Y is equal to 5 times 2 raised to the x power. Okay? And then finally recall that when the data shows an approximate exponential relationship, you can model it with an exponential function. So I guarantee, ladies and gentlemen, there will be one like this on the test for you. So I'm going to show you exactly how to do it. So on this here, we are going to say 117, 231, 350, 485, 5156, 6, 274, 7, 498. So remember, if you go here and you're looking at it, all right, I went ahead and put it in, but remember, to figure that out, you would add a table, all right? Then you'll go to the second one, and remember, we're going to do our regression problem. So remember, I have to go y equals okay, sorry about that little break there. I cannot find my, I think, let's see if I get rid of that tool. There we go. All right, sorry, I couldn't find my keypad. So remember, you're going to say y, and remember, you have to say sub 1. So we're going to go here, and I think you have to go to here. And there it is. So we're going to say sub 1. And remember, then you have to do the tilde. And then you're going to tell me it is a. Oops. I don't want that. And then again, I'm going to put the B in parentheses. And now I'm going to put it to an exponent, and it is going to be to the x. And let's see here. I think I should have tabbed it there also. To get the tilde up. There we go. And let's see if we can zoom fit it. And there is our exponential. All right, so remember, once you get it in, zoom fit it so that you can see it. All right, So now that we have it there, remember, x has to be 1 also. That's what I forgot to do. So because remember, I'm trying to find an A and a B. So I put that to 1. And there's our curve. All right. So sorry about all of that. I'm not going to redo it. R squared is not clear to 1, which is what we expect. So our answer will be what? Let's see. 8.472 is your A. And your B is 1.79. So remember that as I bring my other screen back up. And what did I say A was? 8.42. So our answer will be Y is equal to 8.42975. Again, look and see what they tell you to do it for. I would have done to the nearest 4 because that's what you're going to start doing. Times 1.7901 raised to the x power. All right. So that's it. Okay, thank you.